Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is length of longest subarray with at most k frequency. Okay, so the problem statement goes like this: that you are given an integer array nums, and an integer k will also be given to you. The frequency of an element x is the number of times it occurs in an array. Okay, so an array is called good if the frequency of each element in this array is less than or equal to k. Okay, so then you have to return the length of the longest good subarray of this particular nums array. Okay, so a subarray, those of you who do not know what a subarray is a contiguous and non-empty part of elements within an array. Okay, so what it means is, let's say this is the subarray. So this is the array nums. So subarray can be any contiguous part, this part or this part. These are all valid subarrays, and this whole array itself is a subarray. Okay, so it cannot be the case like this you are counting this whole as a subarray. So the things are not contiguous here, not contiguous. Okay, so you cannot consider it a subarray. Okay, so it should be contiguous, and that's all for that part of nums array that we are taking. Okay, so you have to return the length of the longest good subarray. I mean the subarray which is in which every element is having frequency either less than or equal to k. Okay, so you have to tell the length of longest such subarray in the given nums array, and two things will be given to you, nums and k. Okay, so let's see how we can solve this problem. Before thinking of an approach, let's look at the constraints also. So as you can see, the length of the subarray is of order 10 raised to power 5, and all the elements are ranging from 1 to 10 raised to power 9. Okay, and k will be ranging from 1 to length of the subarray. So let's see the approach how we can solve this. So for that, what we can do is we will be definitely having a map for frequencies. Okay, so element and then its frequency. Map will be of integer type. To key will be of integer type, value will also be of integer type. So this will be key, this will be value. So let's take one of these examples. Let's take this one. Okay, yeah, so let's mark the indices 0 1 2 3 4 5 6 and 7. So what we'll be doing is we will be using a two-pointer kind of approach. Why we are using that approach? Why not two nested loops and just finding out the subarray? Because of this this constraint, size constraint. Size of array is of order 10 raised to power 5. So if you run two nested loops for left and right bounds of subarray, let's say this is left bound of subarray and this is right bound of subarray, I mean two pointers. Okay, so if you run two loops, for loops for this, your overall time complexity will be of order 10 raised to power 5 square, which will be by the way 10 raised to power 10, or number of operations will be required for that kind of solution. And there is a constraint on the number of operations that you can do in a particular problem, and that constraint is order of 10 raised to power 8 operations. If the number of operations exceeds or become equal to this number of operations limit, this is ops limit, then you may get a TLE and your solution will not be accepted. Okay, so it is greater definitely. So in that case you will get time limit exceeded. So we have to optimize this particular approach. Okay, optimization is required. So we will try to solve it in linear time complexity. Okay, which time complexity I am talking about? Linear time complexity, order of n, where n is the size of the given nums array. Okay, let's say this is the nums array given to you and its size is n. Okay, so now coming back to the approach, we will be improving the approach. Instead of order of n square, we will be using order of n time complexity approach. So what we'll be doing is, initially both left and right pointers will be starting at the very end, very first index, left and then right. Okay, so you will be moving right in this direction, and your left will either be equal to right or will always be less than right. So they will form a window kind of structure. I mean, let's say this is the correct current position of left and this is position of right. So there will be a window kind of structure formed here. Okay, and you will keep incrementing the frequency of each element as you encounter that element with the help of right pointer. Okay, so let's say we encountered one for the very first time, and k by the way is given to be 2. Okay, so one is being encountered for the very first time. Okay, its frequency is right now 1. Now right proceeds further, it comes here. Okay, so we will check whether this, let me check k's value, otherwise it would be a mistake. Okay, it's fine. So we will check whether this frequency is equal to k or greater than k or not. Okay, it is not, so we will move our right. Then comes 2, so 2's frequency will be 1. Then comes 3, 3's frequency will also be 1. Then comes 1, 1's frequency right now will be updated to 2. Okay, so it's still equal to k, not greater than k, so we are just fine. Okay, now left will remain here. I will tell you what's the use of left here. So as soon as you reach 2, its frequency will also be updated to 2. Then you will be reaching to 3, its frequency will also be updated to 2. Then you will be reaching here 1. Now one's frequency is being updated from 2 to 3. Now there lies some problem. Okay, because what's the problem here? Problem is that this frequency is greater than k, so it should not have been the case. What you will do, currently this is the situation. I mean, your right is at 1, this 6th index. Here is your right. Okay, and this is your left. So this is the window kind of thing that you are having. Okay, between left and right pointers. What you will do is that you will fix the right pointer. You will not move it as of now, and you will shrink the window size. How you will shrink the window size? Your left will be moving in this direction. Okay, so when left will be moving in this direction, your when left will move in this direction, your window size will shrink. Okay, and as you are moving left, you will keep decrementing the frequencies which of elements which left is at. So firstly left will be at 1, so then you will keep you will decrement the frequency of 1, so from 3 to again become equal to 2, and then left will be moved one step further. So you will do so till the element that was having frequency greater than k is now having frequency either less than k or equal to k. Okay, I mean it will be definitely equal to k since it's exceeded before and you have just only make one decrement. So you will stop then and there only when this frequency is adjusted of that particular element that was defaulty. So right now your left will be pointing here. Okay, so as soon as this happens, you will know that for this particular subarray at least all things are in order. I mean all the elements are having frequency less than equal to k. So you will see what's the length of this subarray, which is nothing but right minus left plus 1. Okay, because you are counting left also, otherwise right minus left will only give you this portion, it will not include right, that's why plus 1. Okay, this portion only, so this will be left out. In order to include it also, we are adding plus 1. Okay, so now all things taken care of, you are having a length of current subarray which is a good subarray. So you will have a variable max length, keep updating it with this value, and at last you will be returning this. Okay, it's pretty simple. It's just like yesterday's problem. The concept is same that is being applied. The concept is also called sliding window. Okay, you can see for yourself that in this particular window is sliding. I mean you are moving right towards right the very end, and when things are not going according to the conditions described, then you are shrinking your window size with the help of left pointer. Okay, so this left is nothing but shrinking your window size. You can see that this window size, green one is smaller than the blue one, so this is what left is used for, and right is used for growing the window size. I mean it's growing in this direction. Okay, and let's see the implementation. This is the implementation. Implementation wise, it is not that heavy. So left and right pointers will be initially set to the 0th index. Then you will be having a frequency map to store the frequencies of each element, and then while your right does not reaches to the very end of the array, you will keep doing this operation. You will increase the frequency of current element, and then if we are having a problem, I mean if there is an element that is having frequency greater than k, then we have to make some adjustment and shrink the window size. Okay, so this is case when there is an element having frequency less than greater than k, basically not less than. Okay, in that case we will be shrinking the window size and decrementing the frequencies along the way. Okay, yeah, this is then you will be having after you will be exiting this loop, you will be having a good subarray. Then you will update the length of maximum length possible. Okay, maximum length possible. with current good subarray length. Okay, and at last you will return this maximum length. So this whole thing is order of n only, where n is the size of the given nums array. And space complexity wise also, we will be using some extra space because of this map. You can consider it order of n. Okay, because it may arise as there may arise a situation where every element is just occurring once. Okay, so yeah, that's pretty much it. Both space and time complexity wise, it's order of n. Okay, this is the approach. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.